Let's define derivative as slope of a tangent line. In this video, we will formally define a tangent line to a graph at a point. Nasanay na kasi tayo to associate the phrase touch at exactly one point kapag naririnig natin ang tangent line. But in this video, we will debunk such notion about tangent lines. Kapag kasi circle yung graph natin, it's true that yung tangent line, it touches the circle at exactly one point. But in general, hindi totoo na kapag sinabing tangent line, ay matatouch na lang yung graph at exactly one point. Kasi pwede rin natin siyang makita later na it may touch the graph at more than one point or maybe at infinite number of points. Here's a trivia. Alam nyo ba na ang salitang tangent ay galing sa Latin word na tangere, na ang ibig sabihin ay touch. Now we will define a tangent line. And to be able to do that, kailangan natin yung notion ng secant line. So kailangan natin ng isang graph. And then we will select a point doon sa graph na yon. And then we will label that point P. And then we will select another point on the graph, which is tatawagin naman natin na point Q. Then, we will connect Q and P para makabuo tayo ng isang secant line. Ang gagawin natin ay we will let Q move papunta kay P. So, Q will approach P at gagawin natin yon sa dalawang sides. First, nasa kaliwa muna si Q and then, after that, nasa kanan naman siya. And habang ina-approach ni Q si P mula sa kaliwa at mula naman sa kanan, i-observe natin yung itsura ng ating secant line. At ang mangyayari as Q approaches P from the left and from the right, ma-observe natin na mukhang may pinupuntahan yung secant lines natin na iisang position. At tatawagin natin yun na limiting position of all the secant lines QP. Yung limiting position na yon nung lahat ng secant lines, yun na yung tatawagin natin na tangent line to the graph at point P. So if you're thinking na para nating kinukuha yung limit ng lahat ng positions, ng lahat ng secant lines, ay tama kayo roon. So parang ganito nga siya. Here, Q is approaching P from the left. And as you can see, habang palapit ng palapit si Q kay P mula sa kaliwa, yung red line, yung ating secant line, ay yung position niya, ina-approach niya yung position nung ating violet na line, which is our tangent line. This time, we are approaching P from the right. And kung galing man tayo sa right, we have the same observation, which is yung position ng red line papunta doon sa position ng ating violet na line, meaning yung line na yan, yung violet is our limiting position. So, kung manggagaling man tayo sa left or sa right, pareho lang yung pupuntahan natin na position. Thus, yan ang ating tangent line. Now, dahil ang pinag-uusapan natin ay lines, we know na ang isang line ay merong slope. And this is our formula for the slope of a line. And plugging in the coordinates of P and Q dito sa formula, we will obtain the slope of our secant line. At sabi nga natin, yung tangent line at P, yun yung limiting position ng lahat ng secant lines PQ. Meaning, makukuha natin yung slope ng tangent line by evaluating the limit of the slope of the secant line as Q approaches P. And we understand that the expression Q approaches P implies that yung x-coordinate ni Q is approaching the x-coordinate of P. That is, x is approaching x sub 0. Finally, ganito natin i-define yung equation for the slope of the tangent line to the graph at point P. Now, itong slope na to ito na ngayon yung tinatawag nating derivative ng function at the point P. Later, we will use this equation to solve for the derivative of a given function at a particular point. At this point, pag-usapan muna natin yung tangent line at the peak or at the trough. Pag sinabi nating peak, ito ay isang bump, isang high point doon sa graph ng isang function. While kabaliktaran naman si trough because siya ay isa namang low point. At ganito ang nangyayari sa tangent line sa mga points na ito. Peak. So same setup tayo. We select a point sa left and sa right ni P. Then we will draw the secant lines. Tapos we will let Q move papunta kay P. Then titignan natin kung pareho ba yung pinupuntahan na position kung galing tayo sa kaliwa o galing man tayo sa kanan. And as we can see here, pareho yung pinupuntahan natin. So we have a limiting position, we have a tangent line. And as you can see, ito ay isang horizontal line. Same setup tayo for trough. And we are approaching P from the left and from the right. And manonotice natin na mukhang pareho yung itsura ng limiting position natin dito, kagaya nung sa peak. It is also a horizontal line. At base sa mga observation na yon, pwede nating i-claim na ang tangent line sa isang peak or isang trough ay horizontal. And ang slope ng isang horizontal line is 0. Kaya siya 0 dahil we know that slope is the ratio between rise and run. And kapag ang graph natin is horizontal, wala naman tayong rise. So, our numerator is 0. Hence, the slope of the tangent line to a graph at its peak or at its trough is 0. In other words, the derivative of a function at its peak or at its trough is 0. This time, pag-aralan naman natin yung tangent line sa isang sharp corner. So, P here is a sharp corner. And gagawin ulit natin yung ginawa natin kanina. We will select a point sa kanyang left at sa kanyang right. And then we will draw the secant lines by connecting P and the point sa kanyang left and yung point sa kanyang right. At pag ginawa natin yun, medyo matatakpan yung ating graph. Now, we will let Q move papunta kay P. And as you can see, hindi pareho yung ina-approach na positions nung ating secant line sa left at nung secant line sa right. Ibig sabihin nun, wala tayong tangent line. At dahil wala tayong tangent line, wala rin tayong derivative. And although continuous yung function sa sharp corner na P, ay wala pa rin siyang derivative doon. And at this point, pwede na natin ipasok yung ating conclusion na continuity does not imply differentiability. And by the way, another case kung saan hindi nag-i-exist yung ating derivative ay kapag yung point ay isang cusp. Again, kapag ang ating point ay sharp corner or cusp, then wala tayong derivative doon. Lastly, let's talk about the tangent line to a line. This time, our graph is a line. So, si P ang ating point of tangency. So, we select a point sa kanyang left at sa kanyang right, and then we will do the same. We will draw the secant lines, but kapag gagawin natin ay medyo mag-overlap yung mga lines. But, take note na meron tayo dyang line. So, as Q approaches P from the left or from the right, we see na meron tayong meron tayong constant na position. At siya na rin yung ating limiting position. And that position is yun mismong line. So, ibig sabihin nun, ang ating limiting position o ang ating tangent line dun sa line ay yun mismong line. At ang slope ng tangent line ay kung ano mismo yung slope ng line. And that debunks yung idea na a tangent line should touch a graph at exactly one point only. Dahil nga, ang tangent line doon sa line is the line itself. Ibig sabihin, it touches the graph at an infinite number of points. So that also means na kapag ang binigay sa ating equation ay equation of a line, ang derivative nun sa kahit anumang given point ay yung kanyang slope. Now we're ready to solve some items. For the following items, we're asked to compute the f prime of 2 or the derivative of the function at x sub 0 equals 2. And here is our formula. Our first step is to evaluate the function at x sub 0 equals 2. And what we will get is 5. Then after that, we will substitute the values doon sa formula natin. This quantity is the f of x. This one is f of x sub 0. This is x, and this one naman is our x sub 0. At pag sinimplify natin yung numerator, we get 4x minus 8. Then, pwede nating isimplify yung expression. It becomes 4. Now, the limit of 4 as x approaches 2 is equal to 4. So, the derivative of this linear function is 4, which is equal doon sa kanyang slope. This time, we have a quadratic function. Solving for f of 2, we get 14. Then, isa-substitute na natin yung known values doon sa formula. Pag sinimplify natin yung numerator, we get 3x squared minus 12. At ang factors niya ay 3 times the quantity x plus 2 and x minus 2. Now, because we have x minus 2 sa taas at sa baba, we will cancel them. And then, we will apply direct substitution to evaluate this limit. And ang makukuha natin is 12. This is now the slope of our tangent line, or the derivative. Rational function this time. Solving for f of 2, we get 6. Substituting the known values doon sa ating formula, this is what we will get. Then pag finactorize natin yung numerator, may makikita tayong common factor, which is x minus 2. Ika-cancel natin yon, and then we will apply direct substitution. Our derivative here is negative 3. For our last item, banat tayo ng rational function. Solving for f of 2, we get 1. And pag sinubstitute natin yung known values, we have an expression na we cannot evaluate by direct substitution. So what we'll do is we'll rationalize the numerator at imumultiply natin siya sa kanyang conjugate, which is the square root of the quantity 2x minus 3 plus 1. Then, itutuloy-tuloy natin yon, isisimplify natin yung expression until pwede na tayong mag-direct substitution. And what we will get here is 1. So, the derivative of f of x at x equals 2 is 1. So, that concludes our lesson. Sa next na video, we will polish this definition and we will introduce an alternative definition for derivative. So, see you then, and thanks for watching.